Now that we're able to discuss the first part of the graphical representations and the relationships among variables, let's test your understanding, and we've tested your understanding about the relationships among variables and equations and graphs. So this time, let's put into practice what you have um, learned. And we will do that using practice exercises. I prepared here the answers already to practice number 1 and practice number 2 for this lesson that we have. The one that is about relationships among variables. So for practice number 1, you are given a certain situation and your task is to answer the question that comes with the situation using the things that you have learned from our previous lesson. Okay? So it says here, speed is directly proportional to distance. If distance is multiplied by 5, what will happen to speed? So the first thing that you should highlight here is the relationship. It says here direct proportion. And remember, when we say direct proportion, the equation actually looks like this. Y is equal to k and then x. Next, let's use representations for the quantities involved. Let's say that we set speed as v and then we set distance as d. There was no mentioned constant variable, but it's okay since we just let it to become 1. So okay na siya as k. And that says here that if the distance is multiplied by 5, which means that the distance is the independent variable and then the speed is the dependent variable. Now that we've identified the relationship, we've identified the variables and what kind of variables they are, we can now use the method that we used previously, which is this one. Okay, we set the speed as is, and then k, we have the k, and then our x is the d, the distance, and then of course the constant will just become 1. And it says here that you multiply distance by 5, so we put 5 here, we multiply the 2, and the result is 5. Therefore, the answer will be, what will happen to speed? Speed will be multiplied or times 5. Next, it says here that acceleration is directly proportional to velocity. If the velocity is reduced by half of its original value, what will happen to the acceleration? Again, let's find out the relationship. The relationship is direct proportion, and then next, we're going to identify the variables. We have here the acceleration and velocity. Let's set acceleration as a and then velocity as v. And since the one that we are going to reduce by half, its original value is the velocity, it means that our velocity is the x and the acceleration is the y. Okay, so again, we're going to do the method we did from previous lessons. That's a equals to kv. Why? Because nga the a is our y and then the k is our constant, not mentioned in the situation, but that's fine again. And then our x is the velocity. That's why it became a is equal to kv. And then, of course, the constant is just 1. And then it says here the velocity is reduced by half of its original value. So the equivalent of that is 1/2. You're going to multiply it by 1/2. Okay, so 1 times 1/2 of course is 1/2. That's why our answer here will be the acceleration will be halved, or in other words, the acceleration will be reduced to half of its original value. Your keyword here will be the word half. Okay, now let's have example number 3. Acceleration daw is inversely proportional to the square of time. If time is quadrupled, what will happen to the acceleration? Again, our first step is to identify the relationship. It says here inversely proportional. But wait, there's more. Inversely proportional to the square. Therefore, the relationship here is not simply inverse proportion, but inverse square proportion. Okay? And then, let's set again the representations for our variables. Let's say that acceleration will be A. Okay, and then let's say the time will be T. And since time is the one that we quadrupled, it means that our time will be the X. And then our Y will be the acceleration rather. And then let's recall the equation for inverse square proportion. Inverse square proportion is actually y is equal to k over x squared. Okay, now that we've set all those facts, we can use the method again, wherein we retain the A, the acceleration, and then the K will be K, and then the T will be the X. Okay, X squared, T squared. And then it says here that you quadruple the time, so we put here 4, okay? And then we do the operations. We set K as 1, and then we set T as 4, and 4 squared is 16, and the result is 116. Therefore, the answer is acceleration will be reduced by 1/16. Okay? Now let's proceed to number 4. It says here, acceleration is inversely proportional to the square of time. If time is reduced by 1/3 of its original value, what will happen to the acceleration? Again, let's look for the relationship. Inversely proportional. And wait, there's more again, to the square. Therefore, again, the relationship is not just inverse proportion, but inverse square proportion. And we have here again the acceleration. Let's set it as A. And we have again the time time T. And again, the T will be Rx. And the acceleration is again the Y. Okay, we know na the equation which I have written here a while ago. So let's do the method that we usually use. We set A as is, K is 1, and T will be 1/3. Okay, when you square 1/3, that will become 1/9. Okay, and then why did it become 1 times 9? Because in multiplication, if there is a fraction here, you can multiply it so that you don't have any difficulties. You can multiply the numerator by the reciprocal of the fraction denominator. What's the reciprocal of 1/9? That's 9. Okay, and this one is our basis for this one. And 1 times 9 will be 9. Therefore, if you reduce time by 1/3 of its original value, the result is acceleration will be 9 times its original value. Okay? Now that we're done with the answers and explanations for practice number 1, let's proceed to the answers and explanations for practice number 2. For practice number 2, you are shown the equation and your task is to get the relationship between specified variables or letters in the equation. For number 1, we have P is equal to W divided by T. And your goal is to get the relationship between W and P. The relationship between W and P is direct proportion. How will you be able to know the relationship of variables when you are shown the equation? Look at P. P is considered to be a whole number, and W is in the denominator of the other part of the equation. If that's the case, as you can see, if the one variable is in the numerator and the other variable is a whole number, we could conclude that their relationship is direct proportion. Okay? Now let's have number 2. Number 2, PE is just one variable or one quantity is equal to mgy. M times g times y. Now the question here is, what's the relationship between y and PE? And again, if you treat all whole numbers as fractions with denominator of 1, we could say that PE is in the numerator also, and M, G, and Y are all in the denominator. Now we could say that the relationship is also direct proportion because PE, considered as 1, is in the numerator as well as Y. They are both again in the numerator of a fraction which has a denominator of 1. Always remember, kids, that from your basic math principles, all whole numbers, all variables that does not look like they are in fraction are actually fraction forms with invisible denominators 1. Okay? Next, let's have number 3. For number 3, we are given P is equal to F over A, and your task is to determine the relationship between A and P. The relationship between A and P is inverse proportion. How is that determined? Look at A. A is actually in the denominator, while P again is in the numerator of a fraction with an invisible denominator of 1. So, if one variable is in the numerator and the other variable is in the denominator, their relationship is inverse proportion. Again, for direct proportion, both variables should be in the numerator. For inverse proportion, one variable should be in the numerator and the other variable should be in the denominator. Okay? Next, let's have number 4. F sub c is equal to mv squared all over r. Your task is to know the relationship between v and f sub c. I have accidentally revealed it, and here it is. Direct square proportion. Now, why does it have the word square here? Why not only direct proportion? If you're going to look at the equation, FC is in the numerator and V is in the numerator. But look at V. V has an extra square beside it. And that will tell you that the relationship, although both of them are in the numerator, the relationship is not simply direct, but actually direct square. That will be your sign that it is direct square proportion. Both are in the numerator and one of them is actually squared. Now let's have number 5. For number 5, we have f sub g is equal to g m sub 1 times m sub 2 all over r squared. And your task is to know the relationship between r and fg. The relationship between r and fg is inverse square proportion. Why? Let's look at the two variables we are trying to know the relationship of. Fg, again, is in the numerator, and r is in the denominator of the other part or the other half of the equation. So, as a rule, I have mentioned a while ago that if one variable is in the numerator and the other is in the denominator, that's considered to be inverse. Now, again, where did this square come from? The square is determined by this square that come together with the other variable. So if there's no square there, the relationship is just inverse proportion. But since there is a square there, together with the r, it means that the equation is not simply inverse, but inverse square proportion. Okay? So now let's proceed with number 6. For number 6, we have the equation P is equal to mv. And your task is to know the relationship between V and P. Their relationship is actually direct proportion because again, P is in the numerator and V is in the numerator as well. Okay, that's all for the answers and explanations for practice exercise or practice number 1 and number 2. That's all for this video. We will continue our discussion on how to create a scatter graph in the next video. Bye!